It was 11:57 p.m. on March 12, 1928. The dam's caretaker was checking the water level when he heard a sound he'd never forget. Not an explosion, not a crack. It was wet, gurgling, like a bathtub draining, if that bathtub held 12 billion gallons of water. He turned and ran. He had exactly 2 minutes to outrun the largest man-made flood in American history. When investigators arrived, they expected to find obvious sabotage or catastrophic design flaws, but the site told a different story. The concrete wasn't shattered, it was scattered. Pieces weighing thousands of tons had been carried half a mile downstream. The dam didn't explode, it lifted. To understand how, we have to ignore the water entirely. We have to look at what was underneath. The first theory was overtopping. When dams fail, water usually goes over the top, erodes the foundation, and the structure crumbles. Makes sense, right? But here's the problem. The St. Francis Dam didn't overtop. The spillways were barely half full. Witnesses reported the water level dropping before the collapse. So if the water didn't go over, where did it go? Underneath. Let's talk about geology. The dam's eastern side sat on solid granite, the gold standard, bulletproof. The western side, an ancient landslide deposit called schist. When wet, schist turns to grease, literally. The coefficient of friction drops to near zero. But here's the kicker. The engineer, William Mullahand, knew this. He inspected the foundation personally. So why didn't he see the danger? Because the danger was invisible. It wasn't in the rock, it was in the water, specifically in the chemistry of the water. This is where the story pivots from geology to chemistry, and it's where we find the real culprit, a reaction so slow, so subtle, that no one noticed it until it was too late. Mullahand was under pressure. Los Angeles needed water. The dam was built in record time, just 2 years. To speed up construction, they used hydraulic mining to blast the foundation clean. That water, the same water that would eventually fill the dam, contained a mineral called sodium sulfate. It seeped into the schist, reacted, expanded, turned solid rock into slippery clay. Every day the dam held water, it was digging its own grave. On that March night, the western foundation simply gave way. The dam didn't crack, it slid. 200 feet of concrete moved 50 feet sideways in seconds. The water rushed through the gap, carving a canyon 70 feet deep in the valley below. By dawn, 400 people were dead, entire families washed away while they slept. The dam didn't fail because of a wave, it failed because the ground beneath it turned to liquid. The St. Francis Dam changed engineering forever. Today, every major dam undergoes rigorous geological testing, core samples, chemical analysis. We learned that a dam isn't just concrete and steel, it's a marriage between human ambition and the ground we stand on. And when that marriage fails, the ground always wins.